Hey guys, I'm going to do problem number 10. It says to calculate the magnitude and direction of the Coulomb force on each of the three charges shown in this figure, which I have copied over right here. And this means microcoulombs, which is 10 to the negative 6. And remember to convert your centimeters to meters. So first I'm going to solve for the forces of each of these particles. So these are going to be repulsive forces because they're both positive, and then this is an attractive force. So first I'm going to solve for the force between this particle and this particle, which we know is repulsive. When I plug my numbers into the formula, I get that the force is 90 newtons and it's a repulsive force. Next, I'm going to solve for the force between the first particle and the third particle, which is an attractive force. Plugging in what I know, the distance is this plus this. And I get 43.2 newtons, and it's an attractive force. And finally, I'm going to solve for the force between the second particle and the third particle, which is, after plugging in your givens, you get 67.5 newtons, and it's an attractive force. So now I get to solve for the net forces on each of my particles. So for Q1, it's the repulsive force by Q2 is greater than the attractive force by Q3. So we know that the particle is going to go this way. So we have to subtract this attractive force from the repulsive force to get the net force. So we end up getting 46.8 newtons for the first particle. And for the second particle, it's a repulsive force this way and an attractive force this way, so we add both those forces. So that means we get 90 newtons plus 67.5 newtons, so we get a total of 157.5 newtons for the second particle. Finally, for this last particle, it is an attractive force for both of them going this way, so we're going to add the two forces. So we get force 1,3 plus force 2,3, and you end up getting 110.7 newtons. And that's the entire problem. Thanks, guys.